Hey guys, so we're going to talk about acids and bases. There was an assignment on Google Classroom. Some of you might have gotten started early on it, but I'm just going to go through them. So, acids and bases are chemical compounds that we use in our day to day that are quite important. In grade 10, you'll learn about naming acids and bases. It's not something we'll get into in grade 9. But just to make you aware of some of the household products that you might see that are acids or bases, and maybe why we have to be a little cautious when taking care of them or using them. So typically, when you're looking at an acid, there is a certain concentration, a certain amount of hydrogen that is present, and that is what defines it as being an acid. So we have an example of like hydrochloric acid. So it's hydrogen and chlorine. When we have a base actually has an oxygen and a hydrogen bound together, and that compound is called a hydroxide. It is a polyatomic ion. So it's a compound, two elements that are bound together, and they themselves hold a charge. So hydroxide is a compound that is in a base, and it's what kind of defines it as being a base. So here in the middle in this image, we have sodium hydroxide, and so that's a base. Okay, so in a formula, when you do get to grade 10, you'll notice that when you're looking at an acid, so this pink one to your left here, you'll see a hydrogen at the beginning of the formula. And so that's what's kind of defining it as an acid, because there's hydrogen present. When you look at a base, you're going to see a hydroxide at the end of the formula, OH. And that's what gives it that characteristic of being a base. And if you have something that is neither, it's neutral, not an acid nor a base, you'll notice that you don't have a hydrogen present or a hydroxide present. So here I have sodium chloride. Okay. Again, naming and those conventions and a lot of those rules you're going to go over in grade 10. You'll learn about them. But for acids and bases, you guys might have heard of this before. It's called a pH scale. And so a pH scale is how we measure whether a substance or a solution is acidic or basic. And a pH scale starts at 1 or 0 and it goes up to 14. So everything in red and to your left is considered an acid. So there's going to be a high concentration of hydrogen present. Some common things that are very acidic, if one example is your stomach. So your stomach is actually very acidic, and it's acidic because it breaks down lots of protein that we eat. And so if you were to actually stick your hand down your throat and put it into your stomach, it would burn your hand. Okay, so it would really heavily irritate your hand because there is a lot of acid present there. Battery acid is also very acidic. Soft drinks, coffee, lots of fruits also are acidic, and that's why you might see those commercials where they talk about your enamel breaking down your teeth. That is what acid's going to do. So coffee drinkers typically have stained teeth. And so also things like acid rain. And there is a little video that I would like you to watch from National Geographic that just talks about some of the effects of acid rain. Things that are more basic are going to be on the right-hand side of your pH scale. They're going to be larger in number from 7 to 14. Bases, we're going to get into the characteristics, but they're typically soaps. So baking soda, laundry detergent, bleach, those are all fairly strong bases. And a misconception is that only acids can burn you, but a strong base will also irritate the skin and can do a lot of damage. So that's why you would never drink drain cleaner or bleach, because you would die. So don't do it. Things that are neutral, okay, a pH of 7, so they're neither acidic or basic. Fresh water would be neutral, as well as blood. The cool thing is that blood that's carrying carbon dioxide, blood that has taken waste after your muscles have done work, carbon dioxide, and that you breathe it out in order to get rid of it, that carbon dioxide actually makes the blood that's carrying it a little bit more acidic. So your veins, which carry carbon dioxide, are typically a little more acidic than your arteries that are carrying oxygenated blood, which is kind of cool. So pH is, again, a measurement of how acidic or basic something is. And there are lots of different kinds of indicators. In grade 10, you might do a lab or an activity talking about pH, which would be cool, where you can have different materials. So you can have, your laundry detergent or water or maybe some juice or pop, and you put it in a container and use these different types of indicators. These indicators are called, most of the time, litmus paper. And so litmus paper is special paper that when you dip it into an acid, the paper that is typically yellow in color will actually turn red. And so if you put litmus paper in a solution and it turns red, then it's an acid. And if you put litmus paper in a solution and it turns blue, then it's a base. And so always think blue base, BB. We also have universal indicators, which are a little bit more specific down here. And they'll actually have a chart that you can make a comparison to with the colors. And it'll tell you the actual pH or give you an idea of whether it's a pH of 1, 2, 3, 7, 8, 9, 10. Whereas your litmus paper, if it's acid, if it's red-blue litmus paper, it'll just turn red for an acid, but you don't know if it's a strong acid or a weak acid. And same with a base. If it turns blue, it's not going to give you an indication of whether it's a strong, dangerous base or if it's close to being neutral. So universal indicators are neat because they'll actually change color depending on the actual pH. So red here would be a strong acid, maybe 1 or 2. And then as it turns orange to yellow, it would be more of a neutral solution. And you could say green is neutral, whereas purple over here, purple and blue are strong bases. So universal indicators are cool because they give you a little bit more of a specific pH. Some terms that this might be interesting. Talk about acidity, something being acidic. So it's an acid, so it's a pH of 1 to 6. And then something that is basic, we also can call it an alkaline solution. So something that is alkaline is also another term for base. So an alkaline solution would be from 8 to 14. And you would have this little chart here that would tell you, and you would reference your paper to the chart, and it would tell you a specific pH. So acids, some properties of acids. Again, this will be a little bit of a review in grade 10, and then you'll go over some naming, which will be new for you. But always know that acids are sour in tasting, so that's why your lemons and vinegar, those are sour. They are corrosive, and so what corrosive means is it'll burn. Okay, it'll break down material, whether that's your hand or a piece of metal or some type of substance that you're working with. It'll be a pH of less than 7. It'll turn litmus paper red, and it contains hydrogen. Okay, so that's a chemical characteristic. Bases, on the other hand, they'll taste bitter, and they're slippery. And they're slippery because that's a characteristic of soap, and so soap is a base. Lime is also a base, which we'll talk about in a second. But so it's slippery in its characteristics and its texture. It's a pH greater than 7. It'll turn litmus paper blue, so base for blue, and it'll contain that hydroxide, so this polyatomic ion, O and H, so oxygen and hydrogen bound together. And it's typically at the end of the formula that you would see. So we care about acids and bases because we can use them for a lot of different materials in our households. The acids and bases can be good conductors of electricity. We can use them to break down certain materials. Obviously, we use bases for cleaning solutions, right? So our laundry detergent, our dish soap, and just our body wash itself. And acid also, if you're interested in the culinary arts. It has, certain flavors to it. It's always interesting to add acidity to your food. So it's cool that we learn a lot about acids and bases, and we do use them in a lot of construction and products, household products. A concern with acids is acid precipitation or acid rain. So when we burn fossil fuels, what actually happens is if there's a bunch of sulfur so sulfur, the element in the fossil fuels in the reserves that we're burning, that sulfur will actually become sulfur dioxide in the atmosphere. So it's a gas. And when water is present, sulfur dioxide, this compound, so sulfur and two oxygens, will react with water, H2O, and it'll actually create a compound called sulfuric acid. And sulfuric acid will be acid rain or acid precipitation. And that acid rain, the acidity of it, if it gets into aquatic ecosystems, it'll actually be very dangerous for all the organisms that are in the area. So it'll actually create a lake or make a lake or a pond more acidic and dangerous for all the organisms that are living there. Also, lots of structures, sculptures, buildings, roofing tiles, those can all be broken down by acid rain as well. So there are some precautions, and those are the videos that I'd like you guys to watch. Some ways that we can try and neutralize an acidic solution. And so what happens is in those lakes and ponds, if there is a lot of acid rain because of a lot of burning of fossil fuels, what we can do is we can try and add a base to the water in order to neutralize it. And so that's called an acid-base neutralization. It's a type of chemical reaction, and it is something that you'll have to memorize in grade 10 or know fairly well, but it's not that hard. So typically you'll have a base. So this is sodium hydroxide, and then this is hydrochloric acid. If you have an acid and a base and you combine them together, so you neutralize them, you're always going to get the same products. So you're going to get salt, table salt, and water. Those are your products. Okay, so for our purposes, it's just always good to know acid plus base equals neutralization. So your solution will be neutral, a pH of 7. But the actual products, so these are your reactants, and your products will be some type of salt and water. Okay, and in grade 10, you'll have to know that this is a double replacement reaction. And you'll have to be able to identify it as a neutralization reaction. But for our purposes, just be aware that if you were in a lab for lab safety, if you spilt an acid on your desk, you should go grab a base. And if you pour a base on it, then it will neutralize that substance, so it won't burn you or harm you. Vice versa, if you spilt a base, then you would take an acid and neutralize it. Okay? And that's called an acid-base neutralization reaction. So one process I talked about, when we have lots of acid rain and it creates an acidic environment in aquatic ecosystems, something that we can do is called liming. And so what we do is we take limestone and we actually dump it, just like this picture showing you, into the ponds and rivers and lakes in order to neutralize the pH of the water. And limestone is naturally found, and a lot of times it's found in the sediment of the lake or kind of along the barrier around the lake. And it will leach and fall into the water naturally, but we can kind of expedite this, make it a little faster of a process, and then help neutralize the water by adding it. So we would take seaplanes or helicopters and just dump large amounts of limestone in the hopes that it would neutralize the water and take care of the fishies. Okay. And I'll make another lesson that will be separate from this about organic compounds for this week. And yeah, so hope you guys have a good week. Please make sure that you finish your your pH scale assignment. So what that is I would like you guys to draw your own pH scale like you see in this picture. And I had attached some example images. I would like you to draw your own pH scale, label it so that from 1 to 6, those are acids, In the center, you have a neutral pH, and then from 8 to 14, you have a base. So I'd like you to label it acid, neutral, or acidic, neutral, basic, or base. And then I want you to draw and choose 5 examples of household products that you know to be either acidic or basic and indicate their pH. So if you want to take a soft drink or pop, you could draw a soft drink just like it is here and tell me that it's approximately a pH of 2 to 3. If you want to do a tomato, tell me it's a pH of 5. If you want to do dish soap or hand soap, you tell me it's a pH of 9, drain cleaner 14. So I want you to pick 5 household products and tell me what their pH is and draw them within your pH scale and take a picture and submit it on Google Classroom. Okay, thanks guys, have a good one.